Alright, we're still doing disk and washer, and we're rotating around lines that are not the X or Y axis. So we got a familiar figure here. It's the triangle in the first quadrant bound by X plus 2Y equals 2. But we're going to rotate it around X equals 4. So keep in mind that this thing only goes out to 2, so X equals 4 is somewhere over here. X equals 4. So we're going to spin around this bad boy. Okay? And if you think about what that does, it creates a wedge on one side. It creates a wedge on the other side with a big gap in the middle from the way it looks of it. And since I can't draw three-dimensional figures, just know that it's spinning around here. Okay? So almost like a circular racetrack with an embankment, I guess. Big area in between there. So we got to figure out what's happening here. But we're going around X equals 4, which is parallel to the Y axis. And we have a gap. So that gap means we have a washer. And we need it in terms of X. Excuse me, in terms of Y. We're going around X equals 4. So that's parallel to the Y axis. So we want it in terms of Y. So our volume will be pi integration, and it will be a outer radius squared minus an inner radius squared. Let me move me again. Inner radius squared, and that will be in terms of y. So just looking at this thing, we can tell that the y boundaries are going to be from 0 to 1 because that is the range that y is using. So integration from 0 to 1. Now, from where this axis of rotation is, all the way to the outer is 4 way. So we're at x equals 4, and it goes all the way back to the y-axis. So this r, the big R, is 4. That's the outer. Okay, that's pretty easy. Now the inner goes to the sloped line there, x plus 2y equals 2. But that doesn't necessarily mean that that's what we want here. So the little r, that's the inner. But let's see. We can get this in terms of y. We can take x plus 2y equals 2 and get x by itself, so it's in terms of y. So that would be x equals 2 minus 2y. But that is out to this point. From the y-axis out to our line is 2 minus 2y. And we're going around x equals 4, so we're looking at the other side of that. So more or less, that inner radius will be from this line of 4 over here back to the sloped line. And the sloped line is 2 minus 2y. So 4 is all the way across, but we're taking away that 2 minus 2y. So that inner radius, that little r, that's going to be 4 minus 2 will be 2. And then and then minus negative 2y, so it'll be plus 2y. So let's make sure that makes sense. 4, everything comes out right. So this inner radius will be 2 plus 2y. So let's just give this a shot. So when y is 0 down here, 0 times 2 plus 2 would be 2. So this little radius down here to our axis of rotation, x equals 4, would be 2. And then if we try the top one, y would be 1. So 2 plus 2 times 1 would be 4. So that would be all the way across here, which would be 4. So it makes sense on those 2 points. So we'll just use it. 2 plus 2y. So that's a lot of work to get there. And if you don't clean up, it might make it look like it's even worse. But now we need to push through. Once we have the right setup, it should be fairly easy. So pi from the integration of 0 to 1, outer 4 squared will be 16. and then minus the inner squared, so there's a full. So 2 plus 2y squared would be 4 plus 8y plus 4y squared. Now there is a subtraction there, so let's clean that up a little bit. From 0 to 1, 16 minus 4 would be 12, minus 8y when I distribute the negative, and minus 4y squared dy. So we got to integrate, then we got to plug in. So it's time to move me back up top, out of the way. And let's see here. If I integrate, I got pi times 12y minus 4y squared minus 4/3 y cubed from 0 to 1. So as we run out of space, let's see if we can be kind of constructive here. Let y equal 1, so I get pi times 12 minus 4 minus 4/3, and then minus let y equals 0. Well, that just gives me pi times 0 minus 0 minus 0, so all that's gone. So in the overall scheme of things here, I've got 8 minus 4/3 all times pi. 8 in terms of thirds is 24/3, so it looks like this will give me 20/3 pi. So that seems like it's a, well, 20/3. Let's just do a calculation and see how big that number is. 20 divided by 3 is about 7, but times pi tells me the area is about 21, so that's approximately 20.94 it says for a volume. It's hard to say. I don't see any real issues right now, so I think we did a good job. Okay, it's not a very tall shape. It is going to be kind of wide, but 20/3 pi is an exact answer, and about 21 is an approximation.